This week in class, we are talking about static electricity. And we did many labs with balloons like this. We also have, so it's an old piece of equipment. So this is called an electroscope. And it's a great way for us to see how electrons are moving and how we can use static electricity and learn from it. So let's see if we can answer some questions with that. So the vocabulary we're going to use today includes the static electricity. So it's about electrons that when they go on an insulator, they stay put and they have nowhere to go unless they are in contact with another substance or a conductor where the electrons can leave. We also have the word induction. So another word that is similar or that relates to induction is the influence. So it's influencing electrons without touching them. And the other piece of information that we are using today is electroscopes. Electroscopes is a piece of equipment that allows us to see electrons or the effect of electrons moving. So let's see if we can look for my first experiment. So here's my electroscope, and you could see that I have here two little pieces of metal, and they are hanging parallel to each other. And the whole idea here is that we have a neutral electroscope. So let's look on the drawing to see what it looks like. We have my electroscope here, and we have a neutral electroscope. What does that mean? That means that we have as many electrical charge, negatively charged particles and positively charged particles, in which case here we have a neutral. It's not positive and it's not negative. Now what is interesting now is that if I take the electroscope like this and then I take a balloon and I rub the balloon on my hair, you will see that we can influence the two pieces of metal. I don't know if you can see them moving. As I bring the balloon closer and I move it away, you can see that the little leaves are actually moving. Let's see if I can get closer. So you can see here, they are moving apart. What's happening here is that I'm using the balloon that is now charged to influence the electrons in the electroscope. So first of all, you're going to say, how come we have a balloon that is now negative? So let's see if we can look at a piece of information that will be useful for this part. So we have, let's see, we have this part here. I'm going to go look at this. So on this English version here, we have some materials. So dry skin, leather, glass, human hair, wool, and cat fur. We have here materials that have low electron affinities. Here's an example. If you take your hands and you rub them like this, you will notice that, let's see if I can get the microphone closer, you will notice that the heat on your hands is getting warmer. And the reason for that is we have friction, and friction is causing a little heat. When we are taking, for example, the balloon here, let's look at the big section. So if we are rubbing a balloon on my hair, what happens is that you have friction, electrons get energy, and then they can move around. So if we look here at the affinity series, we notice that the human hair here has a low electron affinity, whereas if you go at the bottom here, we have rubber that has at the bottom a high electron affinity. So that means that if we have rubber, for example, my balloon, that is rubbed on my hair like this, what will happen is electrons on my hair will say, okay, well, I have more energy. Let's see if I can go somewhere else that I'm more welcome. And they will jump on the balloon right here. That means that the human hair will be a bit more positive, whereas the rubber here or the balloon will become a little bit more negative. So here, if you were to just take my hair, what's the result? So here you may have gone to a museum. This is called a Van de Graaff. A Van de Graaff here is a metallic ball here, and we have here a rubber strap. And what happened is that belt, when it goes up here, it collects some electrons and then brings it down, and it gets rid of them. So what happens is you end up with here a metal dome that is becoming more and more positive. And if you're touching that metal ball that is positive, electrons of our body will move away, and hence the overall charge of our body is more positive. So what happens when it's positive? We have here the hair that is standing up on the individual here. And the reason is that all the hair strands are more positive. They want to be as far away as possible from each other, but they're stuck to the head because they're attached, and therefore that's why we have hair like this. So the fact that we have positively charged hair makes it go this way. Perfect. So let's go back here. So I mentioned that if I rub the balloon on my hair, we have my head that is becoming positive and the balloon negative. This week, I brought a whole bunch of balloons in my class, and then we were trying to put a charge on the balloon. We tried to put the balloon on the ceiling. There's a whole bunch of balloons that were sticking on the ceiling. There you go. It is right there. I don't know if I can show you. Let's see. It's right there. You could see it is now stuck. And the reason why it is stuck is that there's a difference in the charge of the balloon and the ceiling. So let's see if I can bring it down. Perfect. So here we can play and create charges. Perfect. We also know that if you have a negatively charged object or a charged object and you bring it closer to the electroscope, we will influence the little pieces of metal here. Now the question is, why do those move? Let's go back into our drawing here. So if I have my electroscope like this, that is neutral, like this one, but here I bring closer a negatively charged balloon. So what happens is that we have here, so let's put the charges there again. So we have plus, minus, plus, minus, plus, minus, like this. The electrons that are in the electroscope, because the electroscope here we have a conductor, these electrons that are here will want to move. So this electron will want to move away, this one will want to move away, and this one will want to move away. The reason for that is that they want to go as far away as the negatively charged balloon. The consequence with that is that we have more electrons at the bottom here. And here we have two laws to consider. We have the law of repulsion and the law of attraction. So here, because we have two charges that are the same, so we have two parts that are same charge, they will want to be as far away as they can from each other. So here, they will want to create a movement like this. And the consequence, let's see if I can do my drawing right here. The consequence is that I'm going to have here an electroscope and two little leaves that are now going apart, because each of them have an overall charge that is negative, and therefore they want to be as far away as possible. So if we bring this balloon close by, if I take away the balloon, the electrons will just spread around, and then we end up with a neutral electroscope. So this is what we've got right here so far. Now the next part is what happens if I am to touch here the electroscope with my finger. So let's see. So if I rub here the balloon, and then here I bring it closer, I have here the two pieces are going further apart. And if I touch with my finger, oh, they just went down. So they went down because my finger was what we call ground, and the extra electrons were able to go through my finger and out of the electroscope. Let's go to the next step. If I have my electroscope like this, you can see it's right, the two pieces, and I have my balloon. My electroscope is negative, and I bring it closer. We have the influence, and it's going further apart. But what happens if I'm touching the electroscope with the balloon? So let's see. Here we end up with the two pieces of metal that are now separate, but they're no longer being influenced by the balloon. Somehow the electroscope has a charge without the balloon. So the question is, what has happened when I touch here the electroscope with the balloon? So here we have a charged electroscope, and let's see what it means. So let's double check. Okay, so we have the electroscope like this. We have the charges, so plus, minus, plus, minus, plus, minus, and plus, minus. Interestingly enough, we bring here a balloon and we touch the electroscope. So what happens is, because this is neutral and because the charges are different, so when you have an object that is neutral, will be attracted by a negative particle and will also be attracted by a positive particle. So here we have electrons that are stuck to by each other on the insulator of the balloon. And what they will do, they will jump on the electroscope like this. So what happens is that we have extra electrons going on and adding a few electrons right here. So here, that's the first thing. So once we are touching this, what will happen? Because they're more negative, they will start moving away like this because they're more negative. Like this. By foreign electrons. So when we take away the balloon, this way, we have an overall electroscope that is now negative. What did we do? We had a neutral electroscope. We brought a balloon and we touched and we added electrons on the electroscope. It's overall negative. It will be going separate ways. So if I have here, we have an electron that is here negatively charged. Where are the electrons from? They're from the balloon. And because we talked about the triboelectric series, this is how we got electrons. We got electrons from my hair right here. Now this is charged. Is there a way to neutralize this electroscope? Well, what we can do, as you will notice, that when I touch it, you should notice something interesting. The two little pieces of metal went down. So what happened is that we have my body that came here, and the extra electrons had an escape route. Instead of being stuck at the bottom, they all came into my body, and therefore it neutralized my body with the electroscope. So when I let go, we have an electroscope that is now neutral. So how do we call this? We call this grounding. So if we have here a negatively charged electroscope, and then we are putting grounding. Let's get another color. I think that'll be better. We have grounding like this. So I use my finger as my body is full of electrons. We have water in our body. It's a good way to stabilize it because there's small quantity of electrons. However, if you are taking electrical piece of equipment, you will notice that you have a ground in electrical system so that it's connected to the ground or to the earth, where there's plenty of electrons that can be taken if needed or given. As soon as you put a ground to the electroscope, so here was my finger, what happened is that the electron will say, well, we were stuck here at the bottom, we have a way out. So the electrons will leave the electroscope, and by leaving the electroscope, you end up with an electroscope that is now back to neutral, like this, with the same number of positive and negative. And now if I take away the ground, I have a neutral electroscope again. So here, let's see if I can show you the experiment again. So we're here, we have a neutral electroscope. Here I negatively charge my balloon. I get it closer. So here there's an influence. The two pieces go apart. If I move away, they go down again. If I touch, I negatively charged my electroscope. And if I put a ground or neutralize it, what happens? The two pieces are coming down, and therefore I have a neutral electroscope again. So that's something to keep in mind. So that is the third part I wanted to show. Now the fourth part I want to show, let's see if it works. So my previous demo didn't work. Let's see if my fifth demo will work. So let's see what will happen. So first of all, we have a neutral electroscope. Like this. Like this. So that works well. We are going to bring our balloon close by. So that's what the theory we're going to do. As soon as we bring the balloon close by, what will happen? The electrons that are closer to the ball here will want to go at the bottom, creating more electrons at the base. The consequence of that will be that the two little leaves will go separately because they are negative. This is, we have here through induction, so through influence, we're able to charge the same charge the bottom leaves here, but we have not touched the electroscope. So that means that this is just through influence. Now, what I will want to do next, I will put a ground right here. When I put a ground, the consequence of this will be the following. The electrons that are stuck here that cannot go at the bottom here will notice that as we are looking overall here, there is a way out for the electrons through the ground. So what we're going to try to do is to have electrons going out here. So that means that as electrons are moving away, we will be neutralizing the electroscope like that. We have here and here. Like this, like this. We will have a neutral electroscope because we have a ground due to the influence of the balloon. So here is the next thing we're going to try. If we have here a neutral leaves here because they are vertical due to the influence and the ground, if I take the ground away, I should still be able to have a neutral electroscope. So the experiment we're going to try to do now is that if electrons have moved out, that means that we have a few more positive than we had earlier. So therefore, when we take away this balloon like this, all the electrons will be moving to spread as far as possible from each other. And the consequence will be to have a positively charged electroscope. Why would it be electrically charged? Is that we influence with the balloon the electrons to go out of the electroscope. So when there's no longer influence of the balloon and we don't have a ground anymore, we should have a positively charged electroscope. Now the goal is to see, will this work? So let's give it a try. So let's see, we have this. Perfect. Let's get some, I need this available for grounding. Okay, let's try this again. We have a charged balloon. It is going like this. I touch it and then I move it away. Oh, it's working. Very nice. Now we have the two leaves that are a bit further apart. It is charged. Let's see if I can try this again. So if I am bringing the negative, they should get closer. Oh, it did work. The reason why it got closer is that it was positively charged. And as I brought the negative balloon, the electrons at the tip here no longer wanted to be at the tip and went down to the two little leaves and creating a neutral a neutral like this, a neutral electroscope due to the influence. It did work. Let's see if I can do it again. It's always fun to see if we can make it work. So we have the two little leaves. We are bringing here. We are trying to influence. We're trying to influence. Okay, it's not happy. It's not happy. I don't know why it's not happy. So let's try this again. We have the two little leaves. We bring this closer. It is charged. Let's see if we need more electrons on the balloon. They go separate ways. Here, and if I bring this away, the two leaves are going further away. Excellent. So that was a question I had. So here I have a positively charged electroscope. And if I take the balloon and I bring it closer, the electrons at the tip will move down, and we have our two leaves that are sticking to each other. There you go. Well, they should not be sticking. They're close, but they should not be sticking. Perfect. That was a question that I asked my students on Friday, and I had a little quiz to say, okay, how can we charge an object through with the induction only? Don't forget that my balloon did not touch the electroscope. So I did. So everybody says they understood. I asked the question, they wrote the answer, and 2/3 of the class couldn't answer the question. And I said, okay, well, so on Monday, we will look at this again, and I figured I'd do a video to show them. And I wanted to share the information with you so that we can be better in our static electricity unit. And then on Monday, I'm going to try to ask them the question again so that they can better understand. Because as soon as we're done the static electricity, we're going into circuits, and that will be exciting.